Alright, physics. So this was where we left off, I'm pretty sure. As far as forces go, and how to analyze them, how to look at them, what some different forces are. Sorry, I'm just bringing up the reference table because I realized that I forgot to do that. And how to kind of apply that to other things. Real quick, I have a reference table. There we go. Now, what I want to do is a little bit more calculation work because there's a little bit more calculation work to be done. So let's check this out. Specifically, the calculation work that I want to do has to do with the force of friction, right? And kind of how to look at it, how to solve for it, right? There's some keywords, phrases, like always, that you can look out for. One of the first is force of friction. But even more than that, you still have to recognize different scenarios. So let's look at the force of friction. Right, so I had said before already that the force of friction is just any force that opposes motion. Specifically, it points opposite of whichever way the object is moving, and possibly more important, it is very dependent on the two surfaces that are touching, right? You have friction because two surfaces are touching and moving past each other, or touching and not moving past each other, right? High friction situation might be that they don't move past each other. Low friction situation might be that they do move past each other, right? If surfaces, well, that's not how you spell surfaces. If surfaces are not other, we call it static friction. Static because they are stuck together, they are still, right? So static is if they are kind of not moving past each other. So you have these two surfaces, and instead of sliding, they're stuck, right? They don't want to move past each other. If surfaces slide or move past each other, then we call it kinetic friction. Right, and I bring up these definitions because we're going to, you're going to see some keywords and key phrases, and as you read and as you kind of think about how this works, hopefully it will make a little more sense. Now, I don't know why oh, that is okay. Now, looking at that reference table that I was just talking about and going all the way to the last page, we were here and we found ourselves now right here, right, with a funny looking equation, or at least a funny looking symbol, which I'll break down. Right, so the force of friction equals mu times the normal force. Now, this is fairly obvious, right? The force of friction is the force of friction, right? Fn is the normal force, and that also is from before, right? Where are we at here? The normal force. All right, so those two are typically fairly straightforward. That mu is a kind of funny looking symbol. It's a Greek letter. It's a Greek letter M in particular. And that Greek letter represents something that we call the coefficient of friction. Now that is labeled, right, on your, that's labeled on your reference table. Doesn't necessarily, like, mean anything right now, just because, right, it's just a funny looking number, funny looking symbol. The coefficient of friction is a constant that is dependent on the two surfaces that we're looking at. So, it's important to recognize what surfaces are we looking at, what materials are we looking at. Because it's a constant, that should be like a nice, nice news to you, because it means that you don't have to memorize anything. All right, going back to that reference table, if you recall, right, about the acceleration due to gravity, it was on the very front page, right here, right? List of constants. Also here, we find some approximate coefficients of friction. You can see that it's material on material, and perhaps there's another modifier, right? And they're very specific. And the reason they're very specific is because it's wildly different from material to material, and it's not something that you necessarily have to know off the top of your head. But you should know how to find it, how to look for it, right? Now, an example question for like how to solve for the force of friction might be something like this. And that'll do. So, a wooden block slides across a wooden table. If it weighs 50 newtons, what is the force of friction between the objects? I'm just going to say the objects. They would say the block and the table, but I'm growing impatient with my inability to write words. Alright, so again, we know that it's the force of friction equals mu times the normal force. Now, there's a lot of information in here, right? First, we have wood on wood. So I know that I have coefficients of friction. I have that it is sliding, so it's kinetic friction. And I have this number right here. The fact that it has a weight of 50 newtons. Now if I look back, right, the force of gravity is weight. So the weight of the block is 50 newtons, which means the force of gravity is 50 newtons. Now this is useful because if I make my picture, here's a wooden table, here's the wooden block, I have the force of gravity, I have the normal force. I'm going to say it's moving to the right. Here's the force of friction. Right? In this case, hopefully it makes sense that the force of gravity equals the normal force. They're just opposite directions. So I might not know the normal force, but I know the force of gravity. It's 50 newtons. I also need the wood on wood, and it's kinetic, because I need to check the coefficient of friction. So I have to go down here, I go wood on wood. It's either kinetic or static, right? I underlined that it was sliding. That's not stuck. That's moving. So that's a kinetic coefficient of friction, which means I'm using 0.3. Right. Now, when I do this, I'm just going to plug in numbers. It equals 0.30 times 50 newtons, and when I do that, I get that it is 15 newtons. So the force of friction on the block is 15 newtons. All right. Now this combined a little bit of, do you know how to make a free body diagram? Do you know how to recognize which forces are which? And do you know how to use the reference table to find some coefficients of friction to find whether it's static or kinetic? All right. I'll do one more example, and then there will be a few for you to practice before you come into school again. All right. So here's the other example. I'm going to keep most of the same stuff. A wooden block sits on a wooden table. Right? You try to push it and fail. What was the force of friction holding it in place? So I have basically the same situation, except Now we're trying to push, but we're failing because the force of friction is preventing us from moving it. It is not moving this time. You try to push it and fail. It's sitting on the wooden table. So this time it's static. So this time I'm going to look, and I'm going to have the same basic equation. Force of friction is mu times the normal force, but this time I'm going to use the static coefficient of friction because I didn't see that it was moving. And when I do that math, I would get 21 newtons. All right, so again, we know it's friction because they ask about friction. This time it says it's sitting and it doesn't move, so that means it's static. And I know the materials are a wooden block and a wooden table. All right, this is not, super crazy. Try the examples. We will go over those in class, and then we will pick up with another force. There are lots of different forces that we're going to look at, so we're just going to kind of keep going along here. All right. Until next time, take care, kids.